Welcome to our 2024 information session on how to. This year we did quite a few updates to the how to workshop from previous years because we've changed the tools and the methods we're using to really speed up the initial part of the process and help people get their designs in shape more quickly and with more confidence. So in this presentation, we're going to tell you a little bit about HAREI and how you can get what HAREI can do with you to help you get increase your home's efficiency and get solar up on your roof. Takeaway from this workshop will be that solar makes sense, it's affordable, and with a little help, you can do this. Very important on this front slide, the HAREI.org website. Everything that we're going to be talking about today is on the how-to website on the HAREI.org site. So you can always go back there for reference. All right, so getting going. What is HAREI? Well, HAREI is a local nonprofit. We're a 501(c) charity, and we're set up to help individuals and small businesses and nonprofits increase their energy efficiency through sustainability and energy efficiency practices, and look at renewable energy for their home and business. And some of our business activities are in home and small business solar installations. And we work on a pay-it-forward model. It's an all-volunteer organization with people coming together to help each other make an impact on getting solar on their homes. So again, neighbor helping neighbor is kind of the model. We're known kind of for our solar raisers. We're the solar raiser people. We've had over 100 projects go through completion since our inception in 2012. And they accumulate to over a megawatt DC of installed solar. Which over the period of time since 2012 has generated 4.4 gigawatt hours cumulatively, which is, that's kind of a number that you'd hear from a power plant. But this is just projects on people's homes. And that's had a real impact environmentally, reducing CO2 emissions by 3.3 tons, and kind of equivalent to about planting 50,000 trees, according to the Solar Edge calculations. So we make solar affordable in southern New Hampshire, and we're making an impact locally, and we're inviting you to join us in doing that. So this is a how-to presentation. So we're going to skip a lot on how solar makes sense. We do have an introduction presentation that we've done, series that we've done, and we'll do again. That gets into how much sense it does make in New Hampshire, but it does make sense, and we will get to some cost numbers later in the presentation. But there's really three ways for you to get solar on your home here in New Hampshire. The first is a lease or a power purchase agreement. These have no upfront cost, but they do come with a long-term contract for the price of power. And in general, these contracts can be pretty complex and not necessarily best for the homeowner. You don't own the system. The system's owned by the company that installed it. And over time, it can become complex. So we don't recommend these power purchase agreements. The second way is to just hire a professional solar installer. With a professional solar installer, there's several companies. I think there's around 30 registered in the state of New Hampshire right now. And there's some excellent contractors. They put together a full proposal, and with a professional installer, it's a lot like other contractors you'd have do something for your home. You contact the installer. They put together a proposal or a bid. They'll generally do everything from the inception all the way through connection. So they'll do all the steps we talk about in this presentation. And that's one of the things that's good about this presentation and good about some familiarity with the how-to pages and HAREIs. It gives you some background, even if you're buying the system from an installer, on what they're going to do and what steps there are for them to complete. So you have some idea of the scope of the project when you're talking to them. In general, they're going to like a better educated consumer, so they're happy for you to understand these things. The third way, and one we're going to spend a lot of time today, is the HAREI model. It's a do-it-yourself model. And in the do-it-yourself model, HAREI provides quite a bit of assistance in terms of education, purchasing power, design assistance, tools, and finally, a razor at the end, where, like similar to an old-fashioned barn razor, we come together to help you do the heavy lifting to get the system completed. There's quite a bit of sweat equity with the do-it-yourself project, but the benefit is a much lower cost, usually about half the cost of what you'd get with a professional installer. And that's something that you know, a typical homeowner can actually do. So with a little help from your friends, you can get this done. All right, so how can HAREI help you? Well, the first thing is learning, understanding what this is about, understanding and learning about your site evaluation, the design and permitting process, and then on-the-job training. By going forward and helping other people install their projects, you get hands-on experience with all the equipment, the nuts and bolts of the systems. You get to see these things being put together and be in meetings where people talk about the things that they're looking at and having to come to understand in order to complete their projects. And through that, you become, it's like an apprenticeship. You become very familiar with the components, so that when you're doing your own design and installation, you not only have all these contacts with people who've worked on these projects and whom you've helped, but you have some experience yourself with how these things come together. We also help you saving money. We have relationships with a number of distributors that give us preferred pricing, and we send these bill of materials, your materials lists that you need to order, out for competitive bid in order to get the best possible pricing. And of course, we help you with labor to keep the cost of labor down as well, culminating, as we said, in the old-fashioned barn raising style solar razor. So we're going to go through a number of steps here on what it takes from the start to the finish in order to get your project together. I'm not going to read through these in detail, but the first step is evaluating your solar potential. And that's really where a lot of people spend a lot of time, and it's where we've done a lot of work this year in changing our processes to bring on a hands-on and structure-led workshop to help you through the initial steps of evaluating your potential, getting to your initial design, and getting your drawings together in order to submit your applications and your permits. So we'll be talking about more about that as we go through this presentation. So let's talk about evaluating your opportunity just a little bit. The first step is understanding how much power you use. The best way to do that is to start with your electric bills. You can download up to 3 years of usage from Eversource if you're an Eversource customer. And you really want to understand your total year usage because it can fluctuate quite a bit from month to month. You want to understand how much sun you get, and that's something that we can help you with in terms of tools. Again, using the open solar modules that we've put together at HAREI, you do get a model of the sunlight impacting the surface, the arrays that you model, assuming that there's 3D data available for your site. If there's not, we can help you input that data, gathering it either from a cell phone app or using a solar pathfinder tool that we can lend. How much power can you expect to produce? So again, Open Solar does a lot of this work through us using a model that's backed by the Nashua Renewable Energy Laboratories. It puts together a projection of how panels on your site will collect energy and what that looks like over the course of the year. And then what will it cost? So this is something where we've put together some data based on projects that we've done at HAREI over the last several years, and we refined that to look at how much things are going to cost looking forward based on averages from multiple projects as a budgetary at the beginning of the project, and then that gets refined later in the project as you get a particular bill of materials and understand what pieces of the job you might contract out as labor through a contractor or an electrician, for instance.
Chris?
Yeah.
Just want to point out that you're not running the latest PowerPoint. I don't know or why that is. I'm not sure which version you have now, but it's definitely not the latest.
All right. Well, that is something I can probably correct, and it may have been with what happened when we did that kind of jump around for a second. 1 second while I look at that for just a minute. Yeah, this one is not the correct one. Let me see if I've got another one up here. All right, I'm going to switch and try to jump to that slide. This is going to be a little bit of live high wire act, so be patient. Now I've got 2 on the screen, one of which is certainly not correct. Okay, get rid of one.
That looks better.
All right, so this is the same slide, only slightly different. So again, step 0 was what was missing that Eric noticed, and that's joining HAREI. So on our front page of our website at www.harei.org, you'll find a join link. You'll also find it on the contacts page to basically submit your data to get in our member database, be attached to our email list for raisers and meetings, and also a place there for you to pay a $40 a year dues if you decide you do want to join. So again, 6 steps really to get through here, and let's move on through those. So let me get to the next slide quickly here. Evaluating your opportunity, and we'll bang through that just a little bit. What will it cost, and how long will it take to pay for itself? So those last 2 questions are really the key ones that people want to understand. So when we talk about how long will it take to pay for itself, we often talk about the payback time, and that's a curious thing to actually talk about, because the day you put the system up on your roof, it increases your home value by approximately what it would cost to have a professional installer put it on your roof. So in reality, it pays back for itself the day you turn it on. But it also pays back over time and offsets the actual investment that you made initially, so that even if you don't, aren't selling your home, are thinking of it in terms of a net worth equation, it pays back over time, and we'll look at that as well. So how much energy do you use? This is actually an important question to ask and a good thing to understand. When people come to us at HAREI, we always look at their bill usage and kind of the just the magnitude of what we would expect given characteristics of their home. Do they have a swimming pool, a hot tub, special equipment or machinery? Does the bill make sense? And in general, it's smart to look at efficiency before looking at how to generate the electricity that you actually need. A lot of times we find things where there's one item that can be changed dramatically that can bring a bill down. There's also just energy efficiency things that can be done that will help you get your bill more in check, even if your systems are reasonably up to date. One of the key things you can do is work with New Hampshire Saves to get an energy audit. And they're generally focused mostly on heating and cooling, but they'll look at other things as well. The efficiency improvements, like I said, can often be more cost effective than just replacing your power source with a solar power source. Some things in particular that we've had very good, that have been very effective is looking at hybrid hot water heaters. Heat pumps are something that can be, allow you to move to electricity so that you can get to more of a net zero type of existence in your home. And the other thing you have to look at is you have to look at what additional uses you might have in the future. So heat pumps, air conditioning, an electric car might be things that you might think about in the future. And you can build those into what kind of electricity you think you might want to be generating in the system that you're putting up. So you put all that together and you find your kilowatt hours per year, and that's the key factor with the way net metering works is how much energy in versus how much energy out on a continuing basis. And as I said before, it can vary quite a bit month to month. Certainly the generation varies month to month based on the inclination of the sun and the length of the day. And then your usage also varies quite a bit month to month, especially if you've got electricity involved in your heat systems in New Hampshire, either through heat pumps or baseboard heat or even the blowers in your traditional furnace. Typically, we see larger homes in New Hampshire between 10 and 20 megawatts a year. That 20 megawatt number would be an alarm to me for any house that was, under 4 bedrooms and wasn't doing some form of electric heat. But we do see numbers like that, for things that are running pool pumps or some other things that are exceptional like that. A house that's tremendously efficient might come in at 5 megawatts a year, for instance. Again, New Hampshire Saves is a great resource. It's funded through your electric rates, so do take advantage of it. There's rebates for equipment, and there are energy audits available. So definitely do check that out. So the next thing in terms of evaluating your opportunity is how much sun do you get? And there's a lot of things to consider here. You want to consider whether you want to be, whether your site is more suited for a roof mount or a ground mount. You definitely want to understand how much shading you have, whether you have large trees or buildings near you that are going to be impacting the sun and how it hits the site. When you think about the sun and shading, you have to think about summer, but you also have to think about winter when the sun is much lower in the sky and things can be blocked. In general, very rough rule of thumb, we like to see sun for a solid 4 hours, 10 to 2, 9 to 1, that kind of time frame, both winter and summer, to know that you're going to have an effective site. Things you can do, if you're looking at roof mount versus ground mount, the roof being higher up sometimes gets more sun. Tree trimming is something you can do, or removing trees. And then, or, moving to a ground mount if your house is in the shade, but you've got some area elsewhere on your property that has great sun. So to measure shade on your site, the primary thing we're looking at right now is, again, in Open Solar. Open Solar includes the ability to model the shading on your site based on 3D data from their aerial database. Now, unfortunately, that aerial database doesn't cover every property in New Hampshire, so you can also get that data through either a cell phone app or through a solar pathfinder, and we can help you out with either of those two things, and then we can back that data back into Open Solar in order to have good modeling of the shade that you're going to be seeing at your site. The next thing is really about the available area you have, whether, what's the area of your roof that you'd be putting it on, are there multiple roof facets or multiple arrays? Again, if you're doing a ground array, how much space do you have? And how that impacts how much power you can generate. One thing I'll say here is that regardless of whether you put in a big system or a small system, the payback is still very good. So in terms of you put money in, you get return back, the size of the system doesn't really affect that. What's nicer about a larger system is you get to the point where you have very low or zero electric bills, or even in a situation where you're accumulating money with the electric company and they eventually have to send you checks. So that's a nice, that's a kind of a feel good of having a larger system. But even smaller systems are, can be quite cost effective in terms of a return on what you actually invest. So looking at the area, there's multiple panel sizes. A few years back, there were really just two panel sizes, a 60 cell and a 72 cell. And they used to call them residential versus commercial, but we install almost exclusively the larger panels wherever they will fit because they're more cost effective. And over the last 2 years, we're also seeing other variations in size, which still kind of fit in the same size ranges, but might be a little bit taller than that 6'8". They might go to 7'4" in order to pick up another 15 or 20% power. So some of these high power panels are now 2 meters by 2.5 meters, which is up to that, or up to about 7'3" or 7'4". And again, that gives you a little bit more weight, so it's a little bit more to carry on the roof. But we pretty much always recommend a 2-person carry. So any of these panels are doable. But you wouldn't want to be wrestling these by yourself, not the larger ones anyway. So pictures here of a ground mount in winter. Another thing that's happening now is there are bifacial panels. So a ground mount like this in winter, you actually do get some benefit from the sun reflecting off that snow and hitting the back of the array. The picture down in the corner is the Solar Pathfinder, which is a device that lets you see that horizon in a single shot that can be analyzed for what time of year you're going to get sun and what percentage of the total sunshine you'll actually see. So moving on to comparing alternative locations. This is something that Open Solar makes very easy. You can open up an aerial view of your site very quickly, lay down some arrays, either rooftop arrays or a ground mount, and look at how big they would be, where they would fit, what direction they're going to face. By kind of looking at the building construction, you can get the pitch information very quickly, and that gives you enough information to look at how large of a system, how much energy it will generate, and what it's going to generate for the year. So very quick feedback on your initial designs. So the rest of the presentation, I'm going to be talking about some numbers, and when I do, it's going to be based on an example system we have in Open Solar, which is a 28 panel, 28 panel, 390 watt panel, single array system that we use to show some numbers for that system of about 10.9 kilowatts DC. So again, talking about roofs and how houses aren't always faced due south. It's important to know that while you do get benefit, the ideal direction for a solar array is going to be just about due south, depending on your shading. If the shading is over on the east, you might actually get some benefit from facing it slightly off south, but basically due south and up around 38 degrees, which gives you the best total energy for the year. A little bit more in the summer than in the winter. But it's important to know that that it doesn't have to be perfect. This chart is a chart from the National Renewable Energy Labs, the NREL, and it basically shows what percentage of the sun's energy you can capture based on your azimuth, east to west, with east being all the way over on one side at 90 degrees and west being all the way over on the other side at 270 degrees. And then based on your tilt, going from 0 degrees at the bottom, dead flat roof, up to a flat wall at the top. And what you can see is it's got these fairly generous circles, and you can stay in that 85% range over a huge percentage of those different angles. And you can stay at 80% even facing due east or due west. on a pitch up to a 5-pitch roof. So, things can be pretty generous, and a lot of times you can make good economic decisions even on an east-west facing roof. So how much energy you're going to generate? Again, this is something where we lean very heavily on the tooling. Open Solar will calculate for you what the energy production looks like based on the array. You start out with an array size in DC at the top, and then that comes down based on the shading model to the annual output in kilowatt hours, which is the same units that your electric bill is done in. And then you can compare that to your consumption to see how much of that consumption you're offsetting and what your bill reduction will be, as well as what you'll consume, self-consume, which is the energy, we'd call it behind the meter. Stuff you use in your home, comes directly from the array, powers the fridge, powers the furnace, charges the electric car, runs the heat pump, whatever it is. Doesn't even go through the meter, the utility never even knows about it. So this graph over here on the right side of the slide shows your demand, your usage is the black line down at the bottom. And it shows the solar energy that can be generated by the array is this yellow, under the yellow curve here. And then what you see is this red is what will get exported to the grid during the time that you're producing solar. So what's happening here is that you're going to be pushing data out, or pushing electricity out to the grid when you're generating heavily, as well as using it yourself. And then at other times of day, you're going to be buying it back from the utility. And we'll talk more about that later and how that works economically with net metering. So the cost calculation. This is something that people really want to understand well in terms of what its costs are going to do solar. So the big costs in doing a solar system, whether it's you buy it from a vendor or whether you do it yourself, are going to be the parts, the permits, and the installation. Those are really your upfront costs. And the big difference with a do-it-yourself is that you take a lot of the installation cost and you turn it into sweat equity or shared cost in the solar raiser. And then the payback, there's short-term payback, which is things that are returned to you relatively quickly. One is a New Hampshire rebate, which currently isn't funded, but would normally be $1,000. They did open it up for a month last fall, and quickly got swamped, and it will undoubtedly get funded again, and they'll open it up again. And the question is whether how many systems will actually be able to get that. The federal tax credit, on the other hand, is rock solid. Federal tax credit was re-upped in the Inflation Reduction Act of 2022 or 2021 rather. Out to, I think, 2032, it's going to be a 30% federal tax credit. And that pays back as at your next tax filing, although it can be done over 5 years if you don't have enough income tax to cover it in a single year. The other way it pays back, the more steady way, is your energy cost saving. This is bill credits on your utility bill. And then through something called renewable energy certificates or renewable energy credits, which are created whenever your system produces 1,000 kilowatt hours of energy and are auctioned off in order to allow other energy producers who don't meet their renewable energy goals to purchase them in order to meet their requirements. So those are the ways that the system pays back. So currently, for an example, 10.9 kilowatt hour system, we'd be looking at parts of about $1.38 a watt, about 13 grand. Permits, don't cost too much, probably only about $50 depending on your town. And the installation really depends on how much you do it yourself. For an electrician, you could spend between $1,000 and $2,000, maybe up to $2,500 with a large system. If you're getting someone else to go up on your roof and do like the rail installation, we've seen that cost anywhere from $1,500 to $3,000, depending on the size of the array. And then ground mounts have much more variability because there's a lot more that you can do. You can buy wholly assembled packaged ground mount systems. You can have people come out and dig foundations for you. You can have people put in ground screws so that you have kind of a no-dig solution. So there's a number of ways that people employ contractors there, and we've seen those numbers go out past $5,000 for people doing contract work on ground arrays. So again, those all figure into your installation costs. So design and costing. Let's talk about some of the things that you're going to be come out of these designs. So when you do your design in Open Solar, one of the things that comes out of it is going to be a bill of materials that is suitable to be submitted for quotation. So the key thing on there is the panels and the inverters. You'll be looking at different panels based on what fits, based on the efficiency of the panels, and to a certain extent, the manufacturers and things we can find out about quality metrics through various testing labs and reports. Inverters, choice between microinverters and string type inverters and optimizers. Mounting hardware on your roof. Again, we'll have some pictures in a little bit. In a hands-on or an in-person workshop, we'd actually have some things for you to touch and hold that in terms of the racks and inverters and whatnot. But we'll get some pictures in a second. But we use primarily Iron Ridge racking, which has an online design tool and bill of materials builder. Very high quality components. And then other components in order to complete the system, the wiring from the array down to your box, various switches, monitors, meters, and components that may be spec'd by your electrician to hook the system up. Again, how much DIY you do is a big decision here. Are you, in general, we recommend that you can do the plug and play wiring between the components up on the roof or under the array, and then from the edge of the array down to the box. We recommend an electrician, but if you're someone who's done something like install a sub panel or route a circuit and are comfortable with that level of electrical work, that is something that can be taken on by a homeowner in New Hampshire legally. Homeowners here are allowed to do their own electrical work. Again, we recommend an electrician, especially if you're not familiar with such things. In terms of contractor help, I talked about a couple things when we talked about the slide in the last slide. We see people getting help with getting the rails up on the roof, getting ready for the riser. We also see a lot of people getting help with the ground mounts, particularly with drilling ground screws or taking care of the foundations for the ground mount arrays. So here's some pictures of panels and inverters. Again, there's multiple size panels and multiple power outputs. So when someone says, how big's your array, and they say 10 panels, that can be anywhere from 5,800 watts down to 3,000 watts. So you can be almost twice as much and be the same number of panels based on the different panel sizes and efficiencies available. The inverter is a component that is required in order to interface back to the grid and power the type of electronics you have in your home. In our homes and on the grid, we use AC power. The solar panels produce DC power. So the inverter is a component that takes in that DC power and converts it to AC so that it can hook to the grid. And most of the system we do are grid tied, which means that excess power can be exported to the grid, and you can get credit for that power to get that return on your investment. The mounting, here's an example of a ground mount with 4 panels on it. This is a simple pipe design that comes out of Iron Ridge with rails, and then very similar rails laid up on the roof. And in this case, you can see that the rails have the electronics already attached for the under panel electronics. in order to hook to the panels. So it's ready for panels to go down and for those cables to be connected and just clicked in place with the click together MC4 connectors. One of the questions that comes up a lot is about batteries, and this is an area where things are changing very, very rapidly. Batteries are often referred to as energy storage systems in the jargon. So when you work with a commercial installer, you'll often see them called that way. And you might see that when you see articles about storage on the web if you research about batteries. There's multiple options. The most common one for HAREI users is no battery, no storage associated with your array. Batteries are not required. Again, we do the grid-tied array. You're primarily using power off the grid, at night and through most of the time in the winter. And then when you're producing power during sunlight hours during the day and also during the winter, you're either using the power directly from your array or exporting it to the grid to buy it back later. And the way that works with net metering in New Hampshire, it's really quite cost effective. If you are going to add a battery, there's kind of a buy-in cost to get started with even the smallest battery. It's about $7,000. And that battery won't power, that battery would power an average house for just a few hours. But then if you want to, get enough capacity that you might ride through 1 or 2 days, you're looking at doubling the cost of the system that you put on with a solar system. So in terms of, just trying to have resilience, a gas generator is still probably the most effective way you can go. But we're also seeing systems where the inverter, the batteries, and the generator can be integrated. So that's all automatic and controlled, and the generator runs to charge the battery when the power is out for just a few minutes or a half an hour, and then runs off the battery for several hours. So it can be a much better system if you're going to run for a while. If you're trying to go off grid, it's a totally different equation, and obviously a battery is required if you're going off grid with solar energy, because with solar, if the sun goes behind a cloud, the power comes down, and you don't want to brown out your fridge. So you require a battery to keep a steady, high-quality power in your home. And then again, you normally would tie in a generator anyway, because if you get into the winter and you get a week of bad weather, you still might need to top off those batteries in order to ride through that period. The other thing going off grid is it's a full system equation. You really have to start with, how are you going to minimize your energy usage? What are you doing about the insulation in your home? What are you doing about heating systems to use, not to overburden your electric system? How are you choosing your appliances and lighting in order to minimize the electric load? So it's a much more holistic thing you need to do if you're going off grid. So battery technology, again, is changing very rapidly. The power density is going up. The cost is coming down very rapidly. We are seeing some towns put in codes about protection and isolation of the batteries from the rest of structures because of because of their perceived risk of fire, which may or may not be justified, depending on the technology that's being used. But what we recommend is that you think about batteries up front and you think about how they would integrate into your system. And the reason we do that, we recommend that, really has to do with the problem that the utilities have to solve in the future, which is leveling how solar comes into the grid. So it isn't all coming into the grid just when the sun is out, but that it's spread out more. And if the utilities can solve that problem, they'll have a much lower cost systems. And so our expectation is they'll either start requiring that, or they'll compensate people for doing it to the point that it's worthwhile to put batteries in. So either way, it makes sense to think about batteries up front and at least plan for them. So here's an example solar design in Open Solar. And what you can see here in the picture is a couple of, well, 3 different rows of solar cells in various orientations. There's notations on there for the meter and a disconnect switch, the M and the D, and for a solar deck where the electricity would go through the roof and come into the home. In the side panel is a summary that comes out of Open Solar, and this comes up pretty much in real time as you do the design. So as you change it and do experiments, you can see this developing. That has a projected price, as well as what the projected offset would be from the federal tax credit. The system size in kilowatts based on the panels you've chosen and how many, and the annual energy production, as well as that graph that kind of gives you an idea of time of day for that consumption. If you have the 3D modeling, you also get a summary of the shading and how that's impacting your array. And from that, you can make decisions about whether you want to do any tree trimming or things like that in order to optimize it. So from the annual energy, or from that open solar design, the next step is really to try to get to the point where you have a good electrical design and you understand how it's connected, and you have what you need to put your permits in for your building electrical permits, and also your permit to connect to the utility, your connection permit. So coming out of the open solar, we've added at HAREI a module that allows us to extract the data into a spreadsheet system that constructs these electrical diagrams and allows you to optimize the wire sizing to keep the efficiency of your system where it needs to be, and then output that so that you have the diagrams available for your permits and your applications, as well as your bill of materials to send off for competitive bid. The tooling that is involved in this and some of the use of these spreadsheets is pretty complex. So we are running hands-on workshops, instructor-led workshops. We've got one starting tomorrow that's already full, but we'll be starting another one in late March and probably a month after that again. What the goal of these instructor-led workshops is to go from, I believe I want to do solar, to the point that you have all the documents in hand, have your permits in place, and move on a materials buy in order to get those materials on site to start a project. So coming out of Open Solar, you also get a summary of the benefits of the system, the annual production, what percentage that is of the usage that you put in. And here's a graph that shows, again, that production in yellow against your consumption, what you put in from your electric bill usage in gray. And you can see here how the time of year varies for the solar production, as well as for the consumption. So in this particular example, in January and February, you're buying power from the electric company. In March through October, you're selling, and then you're buying again in November and December. But over the total of the year, you're producing 30% more than you're using. And that will come back as bill credits through your electric bill. So let's talk about cost and payback for a little bit. So we talked a little bit about cost and how Open Solar gives you a very quick budgetary costing based on the experience of our members right while you're doing the design. But we'll get into just a little bit more. So one of the very important things to understand when you're thinking about cost and payback for solar in New Hampshire is to understand the regulations and how the utilities do net metering. So net metering is basically a system that allows you to be a small-scale electric producer as well as a consumer. So your electric meter is actually replaced with a new electric meter that counts not only how much electricity you're buying from the utility, but how much you're selling every month. And then they subtract the amount sold from the amount purchased, and that comes up with a net usage, and that's what a lot of your electric bill is based on. So the energy you produce but do not use is sent to the grid. And when you send that electricity to the grid, again, it goes out onto the wires, onto the transformer on the street right in front of your home. And usually it's, it doesn't make it past your neighbor's house. It's not like it's going very far. But you get credit for that power as it passes through the meter on your wall. The energy above what your system supplies, from time, when you're not getting sun or your system isn't sized as large as the energy you're currently using, you're buying from the grid, and that's counted on a second by second interval. So that's continuously counted and summed over the course of the month to formulate your monthly bill. So you pay Eversource for the energy you import at one rate, and they pay you for the energy you export at a slightly lower rate, but honestly, not that much lower. About I don't know, 6 or 7% lower for electricity that's used within the same month, and about 15 to 20% lower for electricity that you export and never buy back. So the other thing we talked about in terms of payback is the rebates and incentives. So the federal tax credit is the biggest and most effective incentive that is currently active, and that is 30% of the total cost of your system. So that's all the materials, any actual expense you incur that's directly associated with solar. So that would include things like cutting trees in order to reduce shade. It would include all of the materials associated with the solar array. It would include the building of a structure that is specific to the solar. So for instance, if you do a ground mount, that is included. If you're adding it on your roof, it does not include credits for improvements made to your home. If you're doing structural enhancements specifically to afford the solar, that can be used as part of that credit. The New Hampshire rebate, again, it's not currently funded, but it may be funded again. It seems to come on and off. It has a couple of times. For most of the systems we do, it's a flat $1,000 for any system over 4 kilowatts, and most of the systems we do are. It's basically going to be $1,000. And then the last is something we've mentioned before, which is the Solar Renewable Energy Certificates, or RECs. These are certificates that are minted every time you produce 1,000 kilowatt hours of electricity or a megawatt, and then they're sold at auctions quarterly. And the returns can vary, but they've been over the last 3 years between about $33 and $38 per rec. So that's kind of like 3.5 cents per kilowatt hour when you make it equivalent to what you're paying on your electric bills. Definitely worth making sure when you do your system that you have a utility grade meter as part of your system, so that the RECs that you generate can be certified and sold on auction. So looking at the overall net financial impact, this is again something that comes fairly directly out of Open Solar. It's an area that we're still working with the tool in order to fine tune. This shows that the utility bill savings over the life of this system would be about $65,000. There's an initial net system cost of $14,000. And in this case, that was derived from a total system cost of about $20,000 minus the federal tax credit. So you do have to bridge from when you actually, outlay those costs in terms of buying the materials and installing the system to when, you're going to get the benefit of that tax credit. And that has an estimated net savings over the first 20 years of the system of $50,000. And when you look at that in a little bit more detail, that gives you a payback sometime in your late 5th or early 6th year with bill savings of about $2,500 a year based on a 21 cent electric rate. and rec payments of about $480 a year based on about a $35 rec price. So that's how these systems pay back. What you can see in this slide, the net takeaway is that after an initial outlay, it starts paying back quickly and crosses over relatively quickly. This is kind of equivalent to buying a CD or bond and getting about a 20% return. So it's a very good return on your financial investment. So moving back to our 6 steps, 0 through 6. I guess that's actually 7. Application before ordering equipment. We recommend that you have your application in place before you lay money down so that you know that you're going to be able to use the materials you get. The most important of those is your power company interconnect application. And the reason that's important is because based on the infrastructure that's coming into your home, it may limit the size of the system you can do. And that has to do with how big the transformers are in your local part of the grid, as well as how many other people are bringing energy in, other people with solar systems that are on either the same transformer or the same leg of your utility. The second thing we talk about is the New Hampshire rebate pre-approval. You can't even download that right now, so right now it's not available. Local building permits, you will need an electrical permit and a building permit in general to do these, and that's something that you do with your town. And then finally, the finances. You have to understand how you're going to, pay for this before you go ahead and make that purchase. There are green loans available as well as home equity loans. A green loan is interesting in that it can be tuned to kind of match your existing electric rates in terms of the time of the number of years to pay off. And it doesn't have, it's not a secured loan, so there's no mortgage on your home from it. But the rates don't tend to be any better or even as good as a home equity loan. So a lot of people go with a home equity loan, which then does qualify for a income tax deduction if you meet your minimum deduction threshold. Ordering materials. Ordering materials is something that we've done a lot of work over the last couple of years. Mike in particular, who's on this call, has done a lot of work over the last couple of years to set up systems where we get preferred pricing relationships with a number of vendors. You assemble your complete bill of materials. We get it in shape so it's standardized and familiar to the vendors that we're going to send it to. Most of it is just extracted from the open solar design. And then you need to complete your your mount design for either your ground mount or your roof mount and add that to the bill of materials. We send it out to quote through HAREI so that we have this standardized interface. HAREI has no financial connection to the transaction. So we send it out for bid, making sure that it is seen and gets the preferred pricing. And then it comes back to you as a quote, and you make the decision on which vendor you choose and finalize the transaction with that vendor. We're not involved with the financial transaction at all. System installation. So system installation. Most of the things that we do in the actual installation of a solar array are very much do-it-yourselfer. As a matter of fact, you can do 90% of the work on a rooftop installation with a single 7/16 socket and a torque wrench. But the steps are basically to prepare your mounts, whether that's ground mount, doing footers and some type of structure, and then rails, or whether that's roof mount, doing those rails that we showed in that picture earlier in the presentation. Then you're start the electrical install by mounting the under panel electronics. Those would be microinverters or optimizers, depending on what type of inverter you choose, and recording those positions so that you can tie that into the monitoring software later. And then tying that back to the edge of the array and readying things for your electrician in terms of electrical components, like the disconnect switch, the rec meter, the revenue grade meter, and if you've got a string inverter where that's going to mount. So you're ready for your electrician, even if that electrician is you. And then finally, when you've got that in place, we get your site prepared for a RAISer, which usually involves making sure that the site is safe, that it's scaffolded if it's up at a height, that areas where things might drop, hard hat areas are marked off, and that it's safe for people to access and work on. And then we schedule a RAISer and get volunteers out. And over the last couple of years, we've had tremendous volunteer participation where, when we announce a RAISer, we'll get anywhere from, 10 to 15 or even 20 people show up on site to help out in whatever way they're able. And that makes the projects go very fast. The installation, when you're ready for it, when you go to put your panels up for a typical install like the one that we used as an example here with 28 panels, would probably go up in under 3 hours. So after the system is installed, it's up on the roof, there's still some work to do. The first thing is to get your inspection from your local authority, which is usually your building inspector. And that's required to be signed off as part of the second phase of the interconnect application with the power company. And so when you do that, you can request the power company to do the connection request, and they come out and put on that net meter. And then the system is connected and activated through the software side of your inverter and monitoring systems. If the New Hampshire rebate comes back to life, you can apply for that. There is some forms that you need to do and some work you need to do selecting a REC auditor and auction agent and declaring yourself as a small energy producer to start up the REC process. So those payments start coming through. And then finally, getting all your records together for your federal tax return for your federal tax, federal tax, the 30% rebate on your federal tax credit. So what resources does HAREI have to support you? Quite a few. So first of all is these hands-on detailed design workshops that we're running starting every about 5 weeks. It's a 4-week workshop with 2 hours session once a week. And again, at the end of that workshop, you should have bill of materials in hand, a design that you're confident in, and the drawings you need for all of your applications and permits. We provide project mentor, someone who's worked on a project recently, who you can ask questions to, and we'll work with you to find out things you need to know in order to complete your project. We have twice monthly online working meetings where we discuss the projects and the technologies and help people kind of work through things that they're puzzling over in their minds about decisions they're making or things they have questions on. We have an email working list, which is a very quick way to get feedback from people with broad and disperse experience within our group on some of the issues about understanding your project or some of the technical details or about installation or doing connections. We provide the bid and quotation service for the group buying power, preferred pricing. And finally, we have a set of tools, including the ladder lift that is in this picture in the slide, as well as scaffolding. Just a good range of tools to help you get the job done, so you don't have to buy everything that you will only use a couple of times, as well as the RAISer itself, bringing the labor and the experience to your home to get the job done. So with that, I just want to close saying that, solar in New Hampshire makes a lot of sense. It makes a lot of sense helping the environment. It makes a lot of sense financially for you. And this is something you can do. With a little help from your friends at HAREI, you can take on a project like this and make it happen. HAREI members have taken these projects on. The fastest project we've ever had has been less than a month from the time he decided he wanted to do it to when he flicked the switch and turned on the power. Typically, it's more about 3 months. So we tend to have a situation where people kind of are deciding in the spring, they're making decisions over the summer, and there's a big rush in the fall. So through the workshops that we're starting now, we hope to get more activity earlier in the cycle in the season, and have more of that steadily progress through the year this year. So with that, if there's any questions, I'm happy to answer them. Again, the website is www.harei.org. We have meetings the first and third Tuesday online that are on our calendar, which can be found on our website in the calendar page. The solar raisers are announced via email list as well as on Facebook. And you're free to attend a solar raiser. We will be asking that you sign a release form if you show up on site and that you abide by the safety policies. And then if you want to get going with HAREI, there's an email list and HAREI signups, as well as a place for you to join and pay annual dues on the website on the contact page. So with that, I'll open up to questions.
Great. Thank you very much, Chris. That was a great presentation. Yeah.
Boy, it was flawless.